So today we are looking into the first chapter, theory of structure. Before starting this chapter, we have to understand the loads, their unit and their direction. Both are important. The first is a very simple point load. It is denoted by a arrow, and the direction of the arrow shows the application of the load. If the load is acted downward, it will be shown by the downward arrow, and if the load is acted upward, it is shown by the upward arrow. The unit of force we are always take in our course will be kilonewton or newton, and in most of the cases I will be taking the upward as positive. The second type of the load is uniformly distributed load. Now if we consider this load, then we have to understand the geometry of the loading. In uniformly distributed load, the geometry of the loading is rectangle. I will give you how to differentiate between the point load and uniformly distributed load. Point load, a person is standing or a fan is an example of point load. So if a person is standing on, let us say, one leg or two legs which are not spaced much, then we can treat that as a point load. Now if we are designing a spring of a sofa and a person is standing on that sofa, then we will take this as a point load. But the same person, if lays down on the sofa, hence the spring will be acted by a approximately uniformly distributed load along the length of the person. So in this, whenever there is a uniformly distributed load, the geometry of UDL is rectangle. Its unit will be kilonewton per meter, and height shows this kilonewton per meter, and this is the length. So what is the area of this rectangle? The area of the rectangle will be 10 into 5, height into length, and that is the total load which is acted downward. So the total area or the total load is area under the loading. Again, it is very important to understand that this is area of the geometry, and in UDL the area of the geometry is rectangle, so its area is 10 into 5, 50 kilonewton. The second important thing which you should keep in mind, that the 50 kilonewton load will be acted at the center of gravity, and we can treat in our calculation this 50 kilonewton being a point load acted at center of gravity. This will be cleared in the coming example also. The second, after this, the third is the varying distributed load. It is an advancement of not the rectangular, but there are other distribution of load in a different manner. That's why it is varying distributed load. In this, if you see the figure number 3, this is a triangular loading with the height as 10 kilonewton. It is decreasing, and at 5 meter it will become 0. So what is the total load acted? Again the fundamental will be same, that the total load acted will be 10 into 5 into half, because area of the triangle is half base into height. So the total load acted will be half into 10 into 5, and it will be acted at the center of gravity, which is L by 3 distance from the height. So it will be at 5 by 3. Similarly, for trapezoidal loading, the magnitude of the load is 10 kilonewton meter here, and then it is decreasing gradually to 5 kilonewton meter here. So if you see, the total load will be the area under this, which is half of 10 into 5 into 3, which is the area of the trapezoid. And this total force will be acted at the center of gravity. Similarly, for the semicircle, the total load will be area under this, and it will be acted at center of gravity. Similarly, if a load is uh, cosine, then also we have to understand the we have to find the area. Mostly in civil we don't find this type of loading in static analysis, but if we have to do dynamic analysis, then sometimes we need these type of loadings. So for any function y is equal to fx, we can say that the total load will be the area under this loading, and it will be acted at the center of gravity. Now in our calculation part, the most important thing is we have to convert this total load into the point load for writing shear force equation, or writing bending moment equation, or finding the reactions. So how to convert varying load to a point load? So the simple thing is, find the area under these curves, whatever the area is, and then simply find its center of gravity. So the total load will be acted at this point. I will give you one by one example of each to understand this. So first take a UDL of 10 kilonewton meter, which is 5 meter in length. So what will be its equivalent point load? It will be area under the loading, which will be the 10 into 5, which is 50. It will be acted at center of gravity, so 2.5 here and 2.5 here. Now take the second example. It is a triangular loading with 10 kilonewton meter as its height and 6 meter as its length, and the total area will be half of 10 into 6, which is 30 kilonewton, acted at the CG of the triangle. So 6 meter, so 2 meter from the C point and 4 meter from the A point. Now if I have a trapezoidal, then also the same. It will be half of 2 into 4 into 6, which is this, and I will give you the formula to find the center of gravity of the trapezoid in just a few minutes. So how we find 3.44 and 2.66, I will let you know. Similarly, for the parabolic loading also, we have to do the same thing. Area of the parabola will be 1/3 of the base into height. So this is 8 kilonewton. The distance, I will give you the formula which you have to remember. So if we have some complex loading, or complex means here simple combinations of the loading, then for each we will find the area, its center of gravity, and place that load. So this is a trapezoid. So here also this is a trapezoid. We convert this into trapezoidal and its center of gravity. Similarly, for this parabola also we have done the same thing. I will let you know how we find 4.5, 1.5, 2.64, 3.44. Just don't worry. I will let you know the formula for each. The fourth type of the loading is moment loading. Movement has its unit kilonewton meter or Newton per meter, and it will not be a load, so it is a movement has it is a sign of clockwise or anti-clockwise. Okay, now I will give you all the important formulas of the important geometries which we deal in the civil engineering. These are generalized formula. I request you to remember this because I will be using very often. So if we take the first triangle whose apex is at a distance of A from the left hand side and the total width is B, height is H, then its center of gravity from the point where we are measuring the apex x bar is A plus B, A plus B divided by 3, and area is as common half base into height. As in trapezoid, it is the total area is half B plus L, means if this is A then this B, then the center part will be half of A plus B, so A plus half of A plus B into L. Now x bar and xb bar, they are unsymmetrical, so for x bar we have 2 times of B plus A into L divided by A plus B into 3. Similarly for xb bar, means you are finding the distance from the B height, then it will be 2 times A plus B into L divided by A plus B by 3. The third is semicircle. Since it is symmetrical, so its center of gravity about the y-axis will be at y bar, and about the x distance it will be r and r from the both the ends. Its area will be pi r square, and y bar is 4r by 3 pi. It is important. I will be using this quite often in the coming lectures. Quarter circle, it is not symmetrical, hence we will have x bar and y bar both are equal. So for quarter circle the area is pi r square by 4, quite obvious. Total circle is pi r square, so quarter circle is pi r square by 4, and its xy bar and y by bar is 4r by 3 pi, means the center of gravity has not moved in the y direction but has moved in the x direction, so 4r by 3 pi and 4r by 3 pi. For parabola, the total, it is again symmetrical, so the total area is 2/3 of L into H, and its height h bar is 2h by 5. Just remember this. Area of semi parabola, again I will be using this quite often. So this is a semi parabola which is increasing and then becoming constant. So area is 2/3 of B into H, y bar is 2h by 5, and x bar is 3b by 8. Please remember this, without it will be very difficult for us to do the things. Now the parabolic spindle, the area will be bh by 3, y bar is 3h by 10, and x bar is b by 4. Now this is also one, I feel many students not able to get it very correctly. So I have given you one more formula for using similar triangle. This is also very common in engineering, and we use very quite often, that if A is the height and there is a continuous decrease, and then B is the height at this end, the total this happens in z distance, then at which point this is 0. Okay, so x is equal to a into z, a into z divided by a plus b. Do remember it? Then in the next class I will be taking up the basic, which is degrees of freedom. Thank you.